Okay, shall we go ahead and discuss? Or would you like more time on this? Okay, sure. We'll just prepare the script meanwhile. Bin bash. Okay, let us use tmux. Hmm, Okay, so okay, so we are going to proceed with that. Okay, so see, mm, idea is that there are two things, right? One is that you had to take the integer argument, right, and then check the whether the number is prime or not. So essentially, it will involve a loop, right? I mean, what we have to do is, so assume that the number that we are checking for is in the first argument, right? So we can say like this. Okay, so this is n. Now, what we do in primality checking, I mean, there are at least two ways to do that, right? So you go up to a square root of that number and so on, then check the modulo whether it is zero or not, for some factor. I mean, if it is a factor, then the modulo will be zero, so therefore it will not be prime. Right? We do it the other way, right? So we check for whether it is prime or not. If nothing divides that number, then that's considered a prime, right? That's how we check it. So essentially, we have to loop through. What we will do for simplicity is that we'll loop through in from two to, not from one, because one will divide everything. We start. Maybe we can start with three also, two or three. Yeah, we can start with two. So two and go up to n minus one, right? So basically every potential factor that it could possibly have, we will do modulo with that number and check if it is zero. At any point, if it becomes zero, then it means it's not prime. However, if we finish the loop, like all n minus 1 numbers we have checked, of course, this approach is not the optimal one mathematically, but we are just going to learn the way, the bash way of doing it, in the script. So essentially, we'll do that, and n minus 1 numbers we'll check. If it is not dividing anything, then we'll come out of the loop, right? I mean, nothing divides it, so we'll come out of the loop. Then finally, we'll print prime. So that is the idea. Okay, so let us think about it, how to do that. So there's this command before we start. So I think on the right side we can show that there's this command called seek. SEQ sequence. Okay, so if you give number like this SEQ 5, right, it prints 5 numbers. I mean from the beginning, right? So starting from one, maybe there'll be some arguments with which we can change the starting also. So we start with 2. So this is a nice way of getting that list actually, and then we can loop over that all the numbers. So essentially, let's say I want to check whether 13 is prime or not. Then I'm going to check with every other number, like from 2 to 12. If it any of the factors, any of the potential factors divide 13, then it is not prime. If they do not, then it is prime. So that's the idea. Okay. Only thing is that we have to get rid of this 1, because 1 will divide everything. So we'll straight away say that it is not prime for every number. Okay. So we have to remove that. One way to do that is also like this. So you can say uh, head minus uh, uh, yeah, to do it the other way, right? Uh, there was a way by which you do the other way around also. You want to skip the first one, right? Or other way. Otherwise, you can just check this
So tail minus n plus 2.
plus 2, right? Yeah. Yeah, but what about the sequence itself? Can we can we have something in this? Oh,
Tail
let's do
minus
more.
12.
Yeah, it says no in the sequence itself. It says first last. And also gives an increment. It's like range in Python, right? So you have everything. So what we'll do, we'll say to n, right, for the last. So essentially, yeah, that tail one is also possible. It's correct. I'm trying to do it with this one. So 2, and let's say I want to go up to 13. So it gives me like this. This is fine. Now for everything, sorry, for everything, we will check if it divides or not. So idea is, so we have n here. Now, so for this is a for loop for k in, and then you have to do something like this, right? SEQ, what is that? 2 space $n. You understand what is happening, right? So starting from 2 up until not the number itself, we have to subtract it also, no? So we say mm, like this, right? Yeah. So starting from 2 going up until that number, okay? And this closes the loop. Do. So let's print, not print, sorry. Let's echo. Okay. So echo k, done. We'll see what happens. Okay. All right. So this one chmod u plus x script.sh, and this one some syntax error, I think. Okay, and this one is okay. Sequence 2, I think this part is not correct. I have to remove the dollar there. Sorry. Okay, let's do another terminal first. We understand what happens. So you have this side, or otherwise you can do this side also. So question is that if I have a variable, let's call it n, we'll do it here and then copy that. Okay. So for k in, and let's say you have let's say I have the array as this. Okay, you can assign it now. SEQ to $n. So array will have what? All the numbers. Yeah, you're getting this, no? So idea is for, yeah, we could do this way also. Slightly more easier to understand. So for k in array, do echo k, and then done. There's something wrong in the for loop. Oh yeah, okay, in $array. There's something wrong here. Yeah. Sorry, I'm using the wrong parenthesis, is it? No. Just a second. Or did we miss that? Oh, you do it without the, okay. You don't need the brackets actually. You do it directly. Okay. So you have this directly. For k in array, do it okay. Done. Yeah, it comes. So essentially, that's what we're going to do in this script. Okay. This part is what is causing the issue. Yeah. All right. Maybe we keep a list separately. Okay. So array is all the numbers with which we have to check, right? So essentially, it becomes sequence and uh, n minus one. Okay. So this is the array. This is n. So for k in array, we're going to do this. Okay. Hopefully, should be fine now. Let's see. Yeah, nothing comes up on the screen. Let's do echo array also. See if, okay. 2, and then we are saying n minus 1. Let's do up until n for now. See. Yeah, it comes. So 2 to n. N is, oh yeah, we have to give the argument also. So let's check. Let's say I want to check for 13. Okay. So then, yeah, it comes like this. So you have this array and you're printing all of that. That's correct. To pass the argument. This is fine. Only thing is that we have to subtract also. We do the subtraction here. Okay. Yeah. So we are getting up to 12, right? So whatever number we give, will be getting a list of numbers, starting from 2 up until that number minus 1. Okay, so 12, and then again we just have to do modulo. So uh, if k divides n, that is k modulo. Modulo is percentage, in bash also. Let's see, modulo in bash. Yeah, it's a percentage only, so it should be okay. So idea is if k, let's do it like this, k modulo n, sorry, it's the other way around, n modulo k, okay, equal to or eq, if it is 0, right? I mean, if it comes out to be 0, then let's say we go not prime, that is, because if only one number is such that it is dividing, no, then we are sure that it is not prime, right? So then we can exit directly, right? uh, okay, now assume that I end the loop, like the complete thing is over, and then I haven't exited, meaning if I am here below this loop, it means that I was not, that there was no match, and therefore I still continue the program. So if that is the case, then we know for sure that this is going to be a prime number. So we say prime. I think hopefully the splings are correct. Let me just check the problem statement once. Clear. Okay. So it says prime and not prime. Okay. Yeah. So that's the idea. We are going through all the elements and then dividing uh, that k, dividing n with that k, and then if modulo rather, it's a remainder. Remainder is 0, then not prime. Exit. That's not the case, then prime. Hopefully it should be okay. Let's check. So we have this. So 13, it says prime. 14, not prime. Yeah, that's how you get it. Okay, so let's see. What about 91? It should not be prime. Yeah. Okay, so that's right. So this is done. Now we'll do evaluation. It's a private the specific test case that fails. Test case 4 fails. Okay. Oh yeah, it says that take an integer argument. So are we going to check whether it is integer or not also? Is that the case? Let's see what is there in test case 4. We can copy, right? Or Let's just do cat for now. Okay. Let's see what the specific input is there. So we have practice 7.7 public. Okay, the test case is not here, is it? Okay, the test cases are not given here, but there's an evaluation file. There's test case for fail. Let's see what all is there. Oh, it's checking for one also. Yeah, that's the edge case actually. Yeah, yeah. So that case we have to handle. Actually, what happens is, what will happen with one is, one it says prime, whereas it is not prime by definition, right? E- Even zero and one we'll have to handle separately. Two is correct because it is prime, and so on. So after two, it is all fine because we are starting from two, right? So only thing is one and zero you have to handle separately. That case we are missing. Okay. So we'll just do a check. So essentially, if n is taken, right? So before even doing this, go ahead, please. Yeah.
And sir, negative number also we have to take that.
Yeah. So we can do that also. We can do both. So essentially, let's do this way, right? If this number n is less than or equal to uh, 1. So if it is 1 or 0 or anything below 0, essentially that's what I'm saying, right? LE1 says that. That is the case, then I'm straight away going to say that it's not prime. By the way, for negative, let's say negative 13, we can say it is prime, no? I mean, we are not concerned about the sign as such. Even if they gave negative, it's fine, right? So we should not be saying that per se. So we can just say that, uh, you know, it is, if it is, yeah, can do like this. So it is equal to 1 or you give like this, right? Or n equals 0. Because negative I'm permitting, because there's no problem in that, right? They give negative also, it's fine, right? So essentially, if it is 1 or 0 only, then we are going to straight away say without checking it's not prime because we know. So that is like the base case, we can handle it like that, right? And then say exit fi. So it's fine, right? So what will happen? This is again guard condition sort of, right? Because we're exiting after that. So we don't need an else and so on, right? Because we know if you do not hit this one, if this is not successful, then only you're going to continue. Otherwise, if it is successful, you go inside not prime and then exit immediately. So there's no need for an else, and we can continue like that, linear, in a linear fashion essentially. We don't have other branch too, because we'll straight away exit right after that. So it becomes a guard condition. Okay, I had discussed about that in the previous session also. So this is fine now. Let's see. 1 not prime, 0 not prime. So nice thing is, but yeah, if you give negative, we are starting from 2, no? So it will start saying prime for all those. Uh, okay. Now one thing we could do is, so there's a way to fix it because I want to permit this also. What we will do is this, okay? If n is less than 0, okay, then I'll do what? N equal to n multiplied by -1. That's what I'm doing. So essentially, if it is a negative number, I make it positive before, you see, before proceeding. So I'll replace it with a positive. So if say -13, it will become 13 because we just get rid of the sign, that is okay, and then check for the positive. I mean, for the positive one anyway, we are checking, right? So should be fine, right?
Sir,
Let's see. Go ahead, yeah. Who is asking? May I ask, please?
sir, could you please explain the comments, sir, last comment, sir? Percentage and percentage.
Telugu,
What
your
kind of?
voice is low. Could you please try raising volume a little bit because I'm not able to make sense of what you're saying. Maybe
Sir, could
audio
you
is.
please explain? Sir, could you
Huh.
please explain the comments, sir? Last comment. Comments I'm not understanding. Please explain.
Last,
Yes, yes, that is right. Yes.
which one? This one?
From this onwards. From this onwards, sir.
This onwards. Oh yeah, yeah, of course, exactly. So we begin with that. So essentially, yeah. So n we take, okay. If it is 0 or 1, then not prime. Okay, that's fine. Now if it is negative, then I'm making it positive by multiplying with -1. That is one thing you could do, right? That part is clear. Array. From here, I'll explain what is happening. See, array sequence is a command. Okay. So what it does on the right side, we can see. So if I say sequence 2 2, 10. Okay, so start with 2, go up till 10. That gives a list of all numbers. It's like a range function. In Python, we
But
have
sir,
range.
here n minus 1 is given, sir.
Haha, I'm coming to that. I'm coming to that also. So assume assume that the number that we wish to check for primality is 13. Okay, I want to check whether 13 is prime or not. Okay, in this case we know it is, but we want to check for that. Okay, no spaces. Okay, so what I'm saying, I'll start with 2 and go up until, so let's say if I go up until n without that minus 1, what will happen? So I'm going to check with whether 2, 2 divides n or not, it will not divide. Then whether 3 divides and so on and so forth. So at the end, we'll come to 12 divides 13 or not, it does not divide. Then I come to 13 if I don't do minus 1. So if that is the case, then 13 divides 13. So it will modulo will become 0, right? So essentially I'll say not prime. Because, but it is prime, right? So we should not be checking with itself, that is. So hence what I did is I just subtracted 1 from that. So so the 13 is not coming. That number itself, whatever we're checking for, will not come in the. So this is the list of numbers we are checking. We are dividing by each of them. We divide 13 by 2, 13 by 3, 13 by 4, and so on and so forth. So at any point, if the remainder, this is remainder, right? The remainder becomes 0, we say not prime and exit immediately after that. Because we need not check any further, right? We know if one factor is there, then it is not prime. You see? So that's why we are not checking for 1 and the number itself. That's the definition of prime, right? Prime is divisible by 1, the number 1, and the number itself, 1 and n, right? So we are excluding 1 and n and checking with all other numbers. And if it is not dividing any of them, then we can say it is prime. So that's what we are saying in the next one. Only thing is that this is not efficient mathematically. We could go up until square root of n only, but that part I'm just skipping for now. Okay, I'm checking for all of them. So essentially what happens is, right, so this is the sequence. This is the list of all the factors that may be there. Now for all factors, essentially potentially which could be a factor, we don't know, but it could be. Then we are checking the remainder, right? So if remainder becomes 0 at any point, we say not prime and exit immediately. So remember what will happen if it does not happen. If no number divides n, then I'm going to finish this loop without entering into this if condition. Okay, I'll not enter it, and the loop will be finished. So if that is the case, then we know it must be prime, right? Because I went through all the factors, like all the numbers n minus 1 numbers, and none of them are dividing that particular n. Then it means it must be prime. So I say eco prime at the end of the day, like at the end of the program. Is that okay, Chalukala? Any questions on this?
Yes, sir. Last sir, comment n percentage came in, sir. Here, suppose 13 is given.
Mm-hmm.
Actually, the example if you write, I will understand, sir.
Of
Suppose
course, of course. So I can give it to you.
step by step.
Uh, just a second. This one, yeah, I mean this one itself we can give, right? So yeah, let's do this. I'll just put this. If you put this, no, you get the value. Sorry, not here in the terminal on the right side. Okay, so I'm doing it for this one. So essentially, yeah. So n is what 13, right? And let's say so k we don't have, so k will give something. So let's say 2. Okay. So nothing comes up. Okay, I need to get the output also. Or let's do this way. I just want to get the value right. I'll just do echo. Okay. Yeah. So essentially, see, remainder is coming, right? 13, that is 13, right? So 13 mod 2, or otherwise you can do it like this, right? So 1, it is dividing, right? 2 does not divide, 3 does not divide, like some remainder is there, right? 4 does not, because it is prime, so we know. But if it is 12, what will happen? So at 4, it will start dividing, right? So because 4 divides 12, so you get 0, right? So that's what, this is the remainder. So if the remainder is 0, then we say not prime. Something divides that, then we say not prime, essentially. Is that okay?
Yes, sir. Yes. Thank you.
Okay, thanks. Okay, so with this, we can proceed with the evaluation. So evaluation failed earlier because we were missing on the 0 and 1. Because 0 we were saying prime because the way loop is set up. So we've handled that case now. Even for negative, it will work now. So if you do now, minus 13, it should not say it. Yeah, minus 13, it will say prime. Just a second. Oh yeah, the multiplication, some issue is there. It's okay only, no? Minus 1. Is it because of the bracket? Let's see. Try to multiply by minus 1 essentially. Right. No. Oh yeah, I'm missing the dollar. Okay. Now. Yeah. So you see, Now minus will work also. So essentially minus 14 says not prime, minus 15 not prime, right? Minus 16 not prime, minus 17 will be prime. So we have handled both cases now. And if it is positive, because essentially we're making it positive, right? Right, getting rid of the minus sign, and rest of the things remain the same. So 17 is prime, 14 is not, 12 is not. That's how you do it. And for 0 and 1 we've handled. So 0 not prime, 1 not prime, 2 is prime, so we keep it at that. And 3 onwards, anyway the loop will uh, take care of that. So now sync very well, should passes all of them. Okay, so this was a good one. Okay, so would you like to take a look at the script again, or is it fine? We can move forward, right? I think should be fine. Yeah, see if we can quickly solve the other ones also. Okay, so let's go to 7.8. Directory already there, we had created it beforehand. So okay, so this one is slightly involved problem. Okay, so we think about how to do that. Okay,
Sir,
essentially in this one, yeah, Telukala, go ahead,
could you
please.
please show the script once again, sir, so that I can take a snapshot? Previous question.
Oh, previous question, of course. Mm, you want to see the problem statement for that?
No, 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 the comments script.
Script. Okay. Yeah, what I'll do is I'll just remove the unnecessary new lines so that uh, maybe you can see it at once. All of it. I had given that so that to make it easier to look at, but essentially that's what happens. Yeah. So this is the idea.
Okay, sir.
Okay. All right. So the next one is slightly convoluted. Not convoluted. I mean, it involves usage of the associative array and so on. So this one also we can discuss. You may take some time on this, or we could what we could do is we could move on to week 8 and see what all problems are there, and then come back to it later and try to attempt this. Either way works. Should we move on to the next one? The idea in this question, I'll just give you an outline of how to solve this one. It's easy only, but thing is that you have to be careful with the array and so on. So idea is, see, there's this command called df minus h. Okay, I'll just explain the problem statement. Maybe we discuss solution later. Okay, so df minus h, it'll give you the mount points. So you have partitions, right? So think of it like partitions. You have partitions, right? And all of them are mounted at some location, essentially some path. You know, they are there. So for each of those paths, mount points as we call them, right? There is this disk usage, right? Okay, this partition is using this much of the disk space and so on. So first that it will give df minus h. This command gives us. Okay, so essentially, if you see df minus h in this case, right, it comes like this. So some temporary files, all file systems also there, so that also show up. But essentially, okay, I could do less, yeah, so that I could scroll. So this is the output. Okay, so the first one, it comes like this. We have these columns. It says file system, essentially the type of the file system, and then the size. So used, it says how much, how much gigabytes are used, and how much is available and so on. So use percentage is what we are interested in, you see. So in this case, slash dev slash root, which is mounted on slash, is the actual root file system, it is 73% used, and so on for all the other ones. Okay, so this percentage is what you are interested in. So this part, this column. Okay, now what they are saying is, maybe maybe I'll show you this side. 7.8 show. Sorry. Synchro show. Okay. So what they are saying is, see, there is a slight detail to this thing which we must understand properly. See, we cannot just loop over the list and figure that out. Why? Because see, these are like buckets, right? So it may not be in the sorted order. Yeah, we could sort it and then think about it. Also, that's also one way. But thing is that, you know it says that 0 to 50 we have to print, and all the mount points in these paths, no, slash def slash shm slash run slash log, and so on, all these paths are there, no? So whatever is belonging to whichever category, I have to print it there. So we don't know in advance, what belongs to, unless we sort by the use percentage. That is also one part we can do. Is if we sort by the use percentage, then we know that all the 0 to 50 will come in the first one, so therefore you can put it. So that is one way we could do that, sort by this particular column. Or if it is not sorted, then what we could do is we could just in one run, like one loop, one iteration through the entire list, keep a list of all the use percentages, okay, in an associative array. So create an associative array. So what I'm saying is something like this. So you have, let's say, I have a script. What I'm trying to say is, so you have an array which maps the the percentage, the category with the percentage. So let's say, or we could have multiple arrays also. So let's say array 0 to 50, like that. And in this we are going to put all that, right? And then we have another array because the categories are fixed, right? So 0 to 50, and then you have 50 to 75, and so on, right? Let's say you have 75 to 100 also. I don't know what all categories are there. That's the idea. 100. So this kind of an array we can have, right? So if we loop through this thing in the entirety, and so for every time we see the use percentage, we'll accordingly we'll check the, which category it belongs to, and accordingly we'll add in that array, right? That we can do. Now after we do that, then we have to print something like this. So we say echo 0 to 50, like this is a header will print, right? And all, so then we have to loop for k in essentially array of 0 to 50. We are going to uh, do this. So echo the mount point, and remember we had to store the mount point and not the use percentage. So we had to check the use percentage, this one, right? And store the mount point also, because they want the path, they don't want the percentage is okay, percentage is to check, but we had to print this. So in zero, so this one for example slash def slash root, this will come in the 73 thing, right? So essentially it will come under this array 50 to 75 when we are printing it. So assume that I do printing here, that's fine, and then I done, and so on. And then for the next category I'll print like this. So 50 to 75, right? And then for k in, and so on, in the next array. So in this case, 50 to 75, right? Then we will print. Only thing is you have to print the path, not the percentage, we know. So this is the last part of it. The thing is, how do you construct the array, right? So what I was thinking is that we could go through this, like a pseudo code that I'm doing, okay? So we could go through all lines in the file. We can cat it, right? So we cat it and get the output. The output, let's say, right? Uh, and then we are doing like this. I think there is some code snippet also given for you to easily get that line of the, or each line of the output. So once we get that, thing is that you have to check the use percentage. So maybe you have to use the cut command. Using cut, you can get hold of this column, right? Or because percentage only occurs here, you can use grep also. Using grep you can get hold of the percentage and remove the percentage, and then compare, right? So you compare and then accordingly you put it. So if so let's say if 0 to 50, then add the mount point to 0 to 50 array. That's what, okay? Or otherwise if it is, and so on, essentially whichever category it belongs to. If it is 50 to 75, then you're going to add the mount point. Mount point is the next last column, right? So because you are doing cut anyway, you're getting this use percentage. Similarly, you can get the last column also, right? And you can use grep also. So then in that case you add this to 75. So you are adding the mount point, right? So essentially this list will be looking something like this. So in 0 to 75 you will have something like this, right? Sorry, in 50 to 75 you can have slash like this, right? For example, again pseudo code only. And in this case, for example, you could have slash run, and so on, right? And so on. You'll have this kind of an array. Similarly in this one you'll add, right? Similarly all these things will be there. So once you do this, for each line in the output you check the use percentage and add it, right, in the corresponding arrays, because the categories are fixed according to the problem statement, right? So then uh, once it is added, once the arrays are prepared, then for each category we loop over that simply in the order. So 0 to 50, 50 to 75, and then 75 to 100 lastly.
Sir,
This is the, go ahead please. Yeah.
sir, could you please explain array 050, array 50, T3-2025. Why we have written like that, sir? The right side.
Because there are fixed categories. I'll show you the problem statement on the left side. So essentially, if you see, this is the df minus h command, right? From which we need to do processing. That is okay. But if you see the statement,
Yes, sir. In this problem, we need to categorize, no, sir, each lines in
yeah,
different groups.
5 categories, right? So therefore, 5 arrays will be there, right? So you have 0 to 50, 50 to 75, 75 to 85, 85 to 95, and then you know 85 to 95 greater than 95. So you'll have all these arrays. In this case, I've created only three to illustrate how it will be. But this, because we know beforehand, right? Which are the categories? Categories are fixed; they're not changing. So we can create arrays beforehand because it is easier that way, no, for us to understand. And then again, so because you have to print also, you see. So 0 to 50, and then it says names of file systems, one in each line with usage between 0 to 50. That's what. So you print it like this. So you have 0 to 50, no, coming here, and then after that you print everything that comes under 0 to 50. Then you go to 50 to 75, like this. You see this part, line number 8 here, right? 50 to 75, then everything comes, that comes under that, and then 70 to 525, everything that comes under that, and so on. Greater than 95, everything that comes under that. So this we can do. Okay.
And sir,
So
right side syntax we have written slash run or in the below story slash zero.
yeah, this is just a pseudocode. Please don't. I mean, this may not be the right syntax. Okay, just wanted to illustrate what may be there. Okay, so some things will get added here essentially. Okay, depending on the above loop, this loop, this loop you are having, right, for each line you're checking. So I'm saying add the mount point to this. So essentially, yeah, array will be initialized beforehand. I mean, assume it is there. Okay, this array, these three. Okay, I can copy. Can I? If I copy from this, it will copy the other part also. Anyway, essentially the array is above. Okay, and then the loop comes here. So essentially, yeah, one line in output. Then you add. Okay, check, use, and add to respective array. That's what I'm doing here. Okay. So use percentage, I'll check, I'll add it. And then this part goes. So because the categories are fixed, we know for sure that either of the categories it will belong to. And then you have bin mesh here. Again, this is just outline. We have to do some changes for it to work, but that's the idea. Okay. I mean, you can think about doing it also. It's not a problem. We can come to it later at the end, towards the end, and proceed. Meanwhile, we'll see week 8 questions also. I'll encourage all of you to try this on your own, okay? And then we'll discuss this also. Okay. I hope the problem statement is clear at least. This part, yeah. Anything else here? I think that's all there is to it, right? Yeah. In each category, print the range in one line. Yeah, print the range in one line is this part, echo 5075, right? The header essentially, and then the print the range string, and even if there is nothing in that range, you print it. Let's say there is nothing greater than 95%, right? But still you print that greater than 95, and then nothing will be there. That's okay. But the header itself will be there. This echo has to be there. So for example, nothing is between 50 to 75. Assume. So what will happen? Nothing will be printed right under that, but the header itself will be there. This part will be there. 50 to 75 will be there, but under that nothing will be there. So you start immediately after that 75 to 100, right? Like that. This is okay. And the output we had to redirect to dev null. This is the category. And they are saying some code is given. We can use this also. Like essentially, yeah, reading each line from the df output and echoing that. So instead of echoing the line, you can check the use percentage here and add to its respective array accordingly. Okay. Yeah, and then there is this substitution also to remove the percentage. You see, if you want to compare, no, in the output, it will be like 50%, 75%, right? So if you want to compare, no, you have to make it into a number. So what do? You remove the percentage sign. Percentage you remove, and then you can compare, right? Easily with the LT, GT, LE, GE, all that, right? Similarly, you can compare using the if statements and accordingly put that in the right array. After you do that, so essentially it's the idea of binning. You bin it into different arrays. Once you do that, no, then printing is not a problem. You just go through each of them and print. Okay, DF output it says usually available during evaluation. Is that okay? Shall we
Yes.
move to the next one? Okay. Yeah, so we'll keep it at this, for example, just the outline. Okay, we'll see if time permits, we'll come back to this and try to solve this also. Okay, because it involves some processing. So I wish to also cover the other problems which are there, which are slightly easier than this. Like, so we can finish off with that and then come back and do this one. Meanwhile, you can think about the ways. I mean, I've given you a general outline. I think that's how it is. But like if you can think of other approaches also, which is nice. We'll just put it like this at this moment. Okay. So and then again, you know what? 7.9 also. 7.8 is one, and then you if you see 7.9, what they are saying is a slight modification of the previous problem only. This df minus h. Okay, they are saying only one difference is there. Okay, so if I exit this part, yeah, again. So they are saying no this time. It says if there is no file system with usage greater than 95 and also none in this range, so then you don't print the header also. Okay, meaning you remember we were printing the header no 50 to 75. If it be printed only if there is something in that list. Otherwise, that header will not be printed. That's the only difference between the previous one and the next one. So it says we are going to carry over from problem 8 only. We discuss that, right? So once you solve that one, you solve this one also. Like you can copy that same solution and just add that condition that if the array does not contain anything, right, then you don't print the header. There's a if check before it. You only print when there is something in it, and then under that you'll have all the names. But if but in the previous problem we did not say that. We say you are going to print the headers regardless, even if it is empty, you print it. Okay, so that is the difference. So you can just copy the same solution here, modify it, and it will work here also. So we'll see both of them maybe together. Okay, so then after this, let's see what we can do with week 8. Um, yeah, so ls. Is there something in week 8? Yeah, practice 8.1 and so on, right? So there's some PPA also. PPA for 7, I think we had done it, right? No, we hadn't. Okay, so let's see this one also. Maybe we'll see the problem statement. There are only two of them. Uh, 7.1. Okay. So for this one, okay. Yeah, this is also interesting problem. They're saying you'll have this kind of an odd word and then you have to print the odd numbers, odd numbered ones. So this is again usage of the modulo, right? You loop through the list. If it is mod 2 is 0, if mod 2 is 0, that is even, right? If mod 2 is 1, then it means that it is odd. So if it is odd, then you print it, right? So it's easy to do, I think. You can quickly, I mean, we can quickly do that on the terminal also. So assume that I have a sequence 1 to 10 comes like this, right? So we can do this for k in sequence 1 to 10, do echo k. For now, I'm just echoing, done. So you get this. Now, instead of echoing, I can say if if k modulo 2, because we want to check for even and odd, right? So if it is 1, eq, right? Eq 1. So if it is, I think we have to do right like this. Dollar, yes. So it says if k mod 2 equals 1, then do it is if, right? So then echo k, meaning that number will be printed, and that's it. Otherwise, it will not be printed. So it's fine. Fi, and then this is for the done, right? So here you get it. That's it. One liner only, right? So yeah, going through all numbers, whatever sequence may be, right? In this case, 1 to 10, right? And then having a simple if loop, if condition. It says if it divides to, I mean, if it is not does not divide to, then we print it. Otherwise, we don't. So if you want to get the even ones now, you just EQ instead of 1, you can make it 0. So you can get the even ones. 2, 4, 6, 8, 10. Getting that, right? So this is all there is to this particular problem. Let's have it, no? Let's have it in the solution and see if that works. So just copy this. And this sequence will be given to us as a bash argument, is it? Okay, okay. As command line. Okay, so you have all the arguments there. There are some arguments that are there. So yeah, that we can do also. See, once we filter, no, so we get this right. At those numbers, you have to check the. Hmm, at those numbers, we have to get the arguments, right? That's what they're saying. So slight difference, right? Yeah. So it is not the number that we are picking. Essentially, they are saying that we are going to pick at that location, at that value of that those arguments which are odd arguments, right? So it says first argument, third argument, fifth argument. So you have $1, $2, sorry, $3, $5, and so on. So this we can do, right? Once we filter out like this, uh, then we can do that. But then are they saying how many arguments are there? Yeah, that we can get from that, no? The count of the arguments are there, right? So just a second. Um, the count is, yeah. So if you know that dollar hash will give you the number of the arguments, right? Dollar hash, in this case, it will be 0 because there are no arguments. The idea is that if you give this no, so then in the script, how many ever arguments you have, you get it, right? So we loop over this, the sequence will become this, okay? And then we get it. So maybe we can do that script quickly, no? Let's do that, odd arguments. I've already copied it, bin bash, okay? So this is what we have. If, then, go, and then you have fi, done. Okay, this is what happens. Now just a second, I'll remove the extra spaces. Okay, so that's what we are having. We can remove this also, it's not required. Okay, so now the sequence count is what? Count is your this thing, how many ever arguments are there. So instead of getting that, we start with one, we know that, right? We go up to count. That's what happens. Okay, or you can just say like this directly here instead of adding another. So for all arguments, right, that are provided, because arguments are always numbered from one, right? We know that. So $1, $2, and so on. So all arguments that are there. If the number, the argument number is odd, right, then we print that argument that is okay. So not $k, because $k will give us that number. We want to get that argument actually. Uh, so that is possible to do. Uh, just a second. We have the number of the argument, right? So okay, you can get the arguments like that also. Okay, okay. So one way is this one way, because here if we do $k, it will print the number itself, but we need the argument. The other way is, see, other way is this. So you say you maintain a count. So let's say k. Okay, we start with one. Okay. Now for all arguments in, so if you do this at the rate, you get all the arguments. Okay. So this becomes argument for argument in this. Okay. Now what I'll do is, so maybe we can start with 0, because to begin with there is no argument. Okay, or start with one, I'll increment it later. So this is just to count. Okay, so if k mod 2 equals 1, meaning it is odd, then I'm going to equal the argument essentially. Okay, now if it is done, then I'll just increment the count. So k plus plus. That okay? So here what is happening, I'm maintaining a count because I know the number, I want to know the number, right? Then only I can check for the whether it is odd or even. So I start with 1 because we know we are going to start with the first argument. For all arguments in this script which is provided, okay, if the current number for the argument is odd, then I print that argument at that position essentially. Print that argument itself, not the number. Okay, and then increment k. So for the next, for the second one, it will become 2, right? So it will not be, then it will not be odd. So this will not be printed. We go to the next one and so on. Okay. So
Sir,
this
could
also
you
works.
please explain, sir, step by step, sir, providing the value?
Which one? This one?
Means what happening after the comment? Please write the value.
After which
Sir,
command?
after each comment, sir, what happening, sir? Could you please write the value?
Of course, of course. So k equal to 1 is to start the, so this is like starting the counter with 1. So we know this is the first argument then here. Now for each argument, so if you say, uh, okay, so for example, I can print it, right? So I'll just echo that so that you understand what is happening, right? These are the arguments. List of all args provided to script. Okay, so here it's the for loop and then so on. So up until these two lines, we'll understand what happens. So essentially, if you do chmod u plus x odd arguments, then you can do like this. Okay, so let's say I have a, b, c, three arguments being provided, right? So it says a, b, c, this is the list. This is the list. So echo this dollar at the rate gives us list of the all the arguments that are there, right? So this is a, b, c, these are the three. So this is the first print, okay, that you have essentially. Okay, open it this side maybe 7 7.1. Okay, sorry, not synchro show. I'll just do it like this. So you have ABC, ABC. Okay, so you get this. Essentially, what is happening is in this side I'll explain. So you have k equal to 1, that is okay. Echo dollar at the rate is this line. Okay, so you're getting all the list of all arguments that are there. That's what we need. So this part is okay. This you understand. So starting the counter with 1. So for each argument, do for each, this is for the for all the arguments. So R will contain, so in this case, for example, if I run on the right side, let's say odd args ABC, right? So the first iteration it will contain A, next iteration B, and the next iteration C, and so on. How many ever arguments you have? D, E, F, G, H. Can I multiple? Okay. So you loop through each of them. Essentially, this line is saying I'm going to loop through each of them. Now, K is a different thing. I'm just maintaining it for myself. This is for myself because I know I want to maintain a count. So for the first time, the argument is the first one, right? So this is like a mapping that I'm doing. First argument, K is 1. Okay. So the first time I'm checking if K is equal to 1, not equal to, sorry, if the modulo, K modulo 2, this is K is we are dividing K by 2 and then checking the remainder. If K modulo 2 is 1, which means it is odd. So if essentially this part, if the if k is odd at this point, okay, okay, so if k is odd at this point, then we echo this argument, right? So argument at kth position. You understand what is happening? So k is like denoting the position of the argument and we are looping through all
Yes, sir.
arguments. Yeah, exactly. So if k is odd at this point, argument at kth position we're printing. So because we know, I mean, essentially the way we have set it up. So now once we print that argument, no, we increment the position number essentially, right? So it becomes 2. Next time it comes to it is so that's what happens. And now if you see this side, so A B C D E F G H and odd arcs. So what it will do is yeah, I think the other part I've saved it, right? Yeah, it is saved. Now if I run it again, yeah. If you see for ABC, A for the first time it is odd, right? So A is printed. Now for the next time it is not odd, so B is not printed, C is printed. Now for the long one, D, E, F, G, H, right? So A, C, E, G, which is A is printed, B is not printed, then C is printed, D is not printed, then E is printed, F is not printed, then G is printed, H is not printed. For all of them, it'll happen. Then if it is I will be printed. How many? 1, 2, 3, 4, 5, 6, 7, 8. 8 of them, right? So if it is 9, then G will be printed also, and so on. Okay. So they are now saying that we can have numbers also. In the odd arcs, we can have numbers like in the problem statement we have numbers, right? So 1, 2, 3, 4, 5, 6, 7, 8, let's say, right? Or 7. So we get 1, 3, 5, 7. Okay, if it is 8, 9. But it does not matter whether it is number or a string. Okay. Essentially at that position we are taking. Okay. So this is what happens. Now if you do eval, it should be okay. Hmm. Okay, some of them are failing. Just a second. Can I scroll it? Synchro eval less. Not being able to scroll. Okay. I'll get out of the tmux and then see. Some slight mistake maybe there. Let's see what happens with eval here. Okay, 135. Oh, so they want in this format. Actually, we're printing line by line, right? They want it like this, like on the not like this. So essentially, after echo, yeah, we can do echo minus n, no? Mm, uh, right. We can do echo minus n, or do paste also. Pipe it to paste. So for example, I'm getting this. If I'm getting this odd arcs, right? So A, B, C. Instead of putting like A, C, we have to have it like paste minus S, D. Yeah, if you just do paste minus S, is also fine. Delimiter is space. So you get it like this. We can do this also. Paste. This is easier. The other way is you do echo minus n when you're printing, no? So instead of printing on a new line, you print on the same line essentially. That's what you do. But the only problem with that is that you will not get spaces. That will be problematic. So ABC it'll print like, yeah, it's printing together. That's the problem with that, because you need delimiters. Better to do paste after it. Okay. Yeah. And so this is okay. They want it like this. This text is black is coming, but should be on the same line. So essentially, what could we do? Echo will not work. Paste is okay, but then again, the entire thing I want to move to paste. Yeah. This we can pipe. See if we can do that. So it become a. Not sure if it will become a descriptor like this. It's difficult. What else? Or yeah, one easy way is you do echo minus n. Okay. After every argument, you print a space also. That is. Okay. So now what will happen is, yeah. So only downside is with the last argument we print another space. I'm not sure whether that will be taken or not. Like, at the end. But this is also fine, right? Let's check with this. It does not pass. So we are printing 135 and okay, because keeps on printing space for multiple. Hmm. Okay. Hmm. Extra space comes, no, uh, if it is equal, then we print it, or we could do this way: print before, the same thing essentially. No? Let's see, same thing. Okay. So the only thing is paste. Paste minus d would work. Mm, okay, we are not doing new line, which is okay. Now what about this? Buses, right? Okay, yeah, that's what. So after every argument, essentially, I'm printing the space. I think the previous one did not work because, see, with echo, if you print like a space b, right? So the space comes by default. You know, everything with every argument essentially. So 1, 2, these are the arguments, right? And the space comes. So what was happening is I had added space like an argument here, which was the wrong thing. Okay, and then you have something else. So 2, 3. So you get extra spaces essentially. I mean, the way it was working. Essentially, what you have to do is after you print the argument, you give a space in the same, essentially in the same argument you give it. Okay, not the script or args. Right. So essentially, what I'm doing is printing the argument and having the space after it. Because if we don't have the space, then it will become together. Like it will come like this. Just a second. Where is the evaluation? Right. It becomes together. Right. So what I'm doing is after every echo, I'm just adding a space. That is. So that also works. Sorry, it's not a script. The name is different. Okay. And so essentially printing like this works. Yeah. So it passes all the test cases. Now let us quickly see the other one. 7.2. There are only two of them. Uh, okay. So, okay, analytics maintains the lines by each investor they're interested in with the file name and the format. Okay. Mm-hmm. So the hash value of file name before. Mm-hmm. Okay. Mm-hmm. Mm-hmm. Okay. Okay. In the data you have this. For each of them you have investment rate, and then this is the map. Okay. Okay. Mm-hmm. Okay. So slightly involved problem statement, but nonetheless interesting. So what you have to do is there's a folder called data. Okay, and in data you'll have some investment details from each of those people. Essentially, these are files. Okay, in the data folder, and each file some will contain like this information like this. Okay, so investment from and to. That's what they are containing. So what they are saying is they are willing to transfer it to somewhere else, right? But instead of giving the names directly, right, they are mapping it to some kind of a hash value. Okay, so everyone gets its own unique, and every first name last name is unique, so they get a unique hash for each of them. Okay, and then they pass the hashed files essentially, so they don't the other person essentially, when the files are transferred, they don't know which person it was who has invested this much, let's say, right, and so on for each of them, and then they pass it along. Okay, so in the mm, cat we have this kind of a situation. So now the expected output, this is okay. We are assuming that no two investors have the same combination of first name, last name. So therefore, each of them are unique essentially. Okay, so they are renaming each investor file to hash value before giving to external vendors. Okay, and the map essentially map file. There's a file called map. Data is there, right? Map is there. So in map, we have the mapping essentially, which which is mapped to which. So this hash belongs to this first investor. Second hash to second investor. The file name is given right here. So it's fine. Now the external vendor receive files of several instances named with some hash values. They analyzed and mhm. Okay. So result file is coming from the external vendor. So we had data and map, right? We had data. This was the name. These are the names. We have mapped it to unique hash values, and we sent the map. Not the map. Rather, we sent the hash values to external vendor. External vendor gave us the result. So they only had the hash values, right? So these many. Right. So now we want to know who are these investors. Like we have to map it back essentially, map it back to their names essentially. Right. That's what happens. So this is okay. So that is in result. Okay. The first name and last name contains this. But what is the expected output for that? Expected output they're saying. Oh yeah, instructions are here. To print the sum of investment amounts of all the investors identified by the analytics team. Okay. Okay. Whose names as well as are present in the file result. Okay. So the rest of the instructions were here. What you have to do, you have this result file essentially. You have all these hash maps, hash values, and we know that these hash values belong to some files essentially. So this first one, for example, right, 45 A45BB1, that is, it starts with BB1 and goes up to A45. So this belongs to this particular file essentially. So once we read the cat file, rather we read cat on the result file, we get the hash values. We map to the files and go into each of them, get the investment amount from each of them and sum it up. Okay, that's what happens. So for this one, think yeah, we have to go into each of them and do that. Okay, so this is not that difficult because for map we grep on that and then cut because we have the hash, right? So we go to map, we grep on this, and cut and get the file name. Go into that essentially, and uh, yeah, we get all these investments. Okay, hmm for all of them. It's okay to do that. We'll move forward and do this. So essentially, mm, are we getting the files? Synchronate? No, we aren't. Okay, but in the investment.sh we'll have the files. So how do we put that? Okay, so let us have it in a tmax session. It'll be easier to do. Sorry, new session. Oops. Okay, now control B sheet 5. I'll try to make it larger. The font size is okay, right? You're able to read it. Is it readable? The problem statement and the commands?
Yes, sir.
Okay, thanks. Okay, so question is now, so we'll assume what files are they are already, I mean, already to be present. We are not going to wait for the files to be. I mean, I think they're not going to give us the files. Essentially, we have to do it directly. It's fine. We can do that. So idea is we have a data folder, and under that we have this kind of a name for each of the investors. That is okay. And then we have the map, and then result will come. So we'll assume result is there. So essentially, you have to loop for result. You can start with the result, right? And result, what it will contain? Result will contain only the hash values. This is the result. Result is having hash values. So for each line in result, okay, we look in the map. So we can do grep. We look in the map, right? Map file, and corresponding to that, we'll get the other column. There are two columns here, right? So the hash space or tab, whatever it may be, right? Delimiter we'll use something, space maybe, and get the last one. So corresponding to this hash, we'll get the file, right? Once we have the file names, then rest of it is easier to follow. Okay. So let us try to do that. What is the name? Name is investment. .sh. Okay. So let us read it. No. Mm, Firstly, we'll read the. Only thing is that unless we finish it off, there'll not be a way to know if we are going right or wrong. Mm, or okay, let me see if we have some test cases given. We can get hold of test case. No, that'll be easier to follow. Public, yeah. Okay, you have different files like this. Okay, this is a map. This is the result, and these are the investments. So how do we make it that? Okay, they're storing in one file all the relevant information for the test case. It's okay. We can just do eval. What happens after that? It does not create anything. Oh, we'll go to each of them and okay, okay. It does create it at runtime, meaning when it is running, no, it will create all those. Okay, fine. We can just straight away assume it is there. So how do we proceed then? Investment.sh bin bash. So we will read it, right? Okay. Yeah, we can create our own files and then do it like that. So this is like result.txt. We'll have some result file. Okay, we get it from there. See, one by one, we'll see. So this, for example, I have to close the other terminal just a second. Yeah. So this, for example, may be the result. Okay. We can create our own. Not a problem. This is the result. We have only the hash values. Uh, right. So if we now yeah. So we are reading all the lines, right? It's coming and you're printing it. We have extra line here. Extra line should not be there. Yeah, we are reading it. So not the result, the script. Modify that. Okay. So in the line, and so each line now what you have to do, we have to have a map also, right? And from that map we will get the. So assume that this is the map. Okay. We'll create a map according to our own hash files. Yeah, this mapping. Okay. So this map is something like this. And I'll change the file names and just create, or yeah, or we can copy also from there. So assume that this map is there. Okay, the map. So first step is for all the lines in result, you have to get the file name. Okay, so we have to look into map and then print the file name. So that part we can do easily, right? Let us proceed with that first. So for each line, we grep. So we'll grep line in, or let's do cat. It's better to understand that way. Cat map, because map is there. Okay, and then we grep the line. Line is just the hash, right? This is the hash. So we are mapping on the hash. So for each of them it will map, and then we have to get the other one essentially. So then we can do cut. What is the delimiter there? Space, huh? Let's see. In map must be a space. Yeah. And you see there are no other spaces. So this way we can split by space here. There's a space there. So essentially, uh, yeah, we have map and grep on the line, and then we cut based on the space and get the second field, that is. So get the file name essentially. Okay. So if you run this now, yeah, you see. So based on what is there in the result file, I'm looping over the result file, and in the map accordingly, I'm getting the names of those files. You see, up until this is clear? You're following? Okay, good.
Yes, sir.
Very good. So essentially, I'm looping over the which file? Result file. Okay, result file. I'm looping over that. For each line in result, I'm checking that same line in map and getting the second column, which is the file name. So I get the I do a reversals of sorts, right? So we have hash, we do a reverse matching, and we get a file name. So this part is working. Okay, now from here it's easy. So each file you are going to, okay, assume that there is file. You're going to each file and investment amount, you have to sum it up. Okay, so these files, can we get the, oh no, we will not have all of them, right? Yeah, we create a copy of this thing multiple times. Okay, so let's say I say touch person A, person B, person C. Okay, so this is like CD, no, carrier data, and then CD data, and then so I'm creating a data folder, going to data, then touching on these three files that are there, and I'll go to, yeah, now person A is blank, but I'll just uh, look like look something like this. Okay, let me change the numbers because this assume is the first one, right? I think I can remove the other two. Okay, and then CP person A to multiple I can create, right? Multiple copies person A, B, C. Okay, now so A is okay. Now in B I'll change. So maybe, yeah, maybe let us have some easy thing. Okay, so let's say this is 100. Person B, let's say it is 210. So 310 in total. Okay, till now. Then we have this 340 or 240. Okay. So what will happen? 310 and 200 is 500. 550. The total sum should be, right. I mean, I've just given these numbers so that we understand the sum is happening properly. Okay, so if you see now person A like this, person B is like this, person C is like. So this is like the investment. Okay, so you have yeah, 450 and 100, 550. 550 should be sum. So you have the data folder now. Now in the investment, what you have to do, you have to go to, so map also I have to change. I'll assume the first one goes to person A. Okay, because anyway, however the mapping is, you can get it, right? Depends on what the map is given in the question. That's not a problem. Goes to B. This assume goes to C. Our objective is to just sum it up. Okay. So now if I run that script again, uh, right, we get this fine now. So from here onwards, we know what to do. So we go, yeah, we go to each of them and then mm, grep on an investment, right? So yes. So we get this. So essentially, you can put this into an array also, right? and this is for, yeah, sum. Okay, so sum we can instantiate to 0. To begin with 0. Okay, we get the file. This is the file. Okay, the file name for each investor, that is. Okay, now this file we had to go into that. So cat file, then pipe to grep, and we want what? Investment. So this will give us the amount, right? Just a second. How is the format? You get this. So you map on that. Then again, um, again we can cut. Get the second one. Get rid of the dollar. It's possible to do, right? So, oh yes. So if you run it now, see all the investments are coming now. Essentially, if you run right, because I'm so each file is there. Now I'm going to each of those files one by one and running grep on this particular pattern, which is investments. I'm getting all the investments, right? So essentially idea is now it is easy for us to do, right? Essentially remove the dollar, get only the numbers and sum it up. Easy enough. So we get the investments now. If we cut it also, cut to the delimiter being space again, second field. Okay, so if you see now, yeah, so this we get, and then after that what we could do, tr to get rid of that dollar symbol, because you need to sum, right? So you have to remove that. Okay, makes sense. Fine. Is it okay till now? Following?
Yes, sir.
Very good. So this is now removed, and so now I'll show you one thing. So to sum it up, and there's one way is to, because we are maintaining the sum, right? Yeah, one way is to just add it. There's other way also. You're getting it one by one. Yeah, we are getting one by one, right? It's fine. Okay, fine. So this is like amount. Let's call it amount. Amount is this. Amount is, you're getting the amount, removing the dollar from there for each person. Okay. Now it's easy. Sum equal to the current sum plus the amount. Okay, I'm just adding it. Whatever the current sum may be. So current sum will start with 0 and then sum it up. So you get it. And then we equal the sum. So we should get what? 550 in our case. Oops. Summation is some issue there. I think missing the dollar again. Okay. We're getting 550, right? That's how it is. So I just go through the script again. So sum, we want the sum of all the selected investors essentially. So selected is meaning whatever is in the result, and result is containing the hashes of, you know. So think of it like this: ID of investor, something like that, right? Hash. It's a hash. So in result we have all the hash of the selected investors, for example. So this is given to us result. So for each investor, I'm doing this. I'm going through that, and then I'm getting the map, right, and grabbing on the hash. So this line is hash, essentially this part. This line is hash. Each line is for each hash, that is for each ID in result. Okay. So I'm checking for that ID and getting the second field. So get file name path for this investor ID. That's what happens. Okay. Amount is, so then once I get the file here, I'm doing cat on that file. Then I get the file path, right? So I get the path, I get the file, and grab on investment, get the, so get amount invested by this person, for example. Okay, and then again, so this is easy. Sum equal to sum plus amount is what is happening, and I'm passing this to equation. It's fine, right? Any questions on this? Should be clear. Okay, so we will evaluate this, see if it works for the other one also. It says no such file directory result. I think since we have added extra things, no. I think is it result or something else? Result.txt or what's the name? Result only, not txt. Okay. So remove txt from there. The .txt is not there, just the result. Okay. Sorry. Passes. Okay. So that's how you have it. Okay. All right. Now what else we have? Hmm. In 8, how many ever questions are there? Let's see. 5 of them, right? Uh, the practice ones, and is there a PP also? PP 8.1, 8.2. PP we'll do after the practice one is done. Okay. So we'll see these 5. 8.1 up to 8.5. So let's see. 8 dot. Okay. So the first one. Okay. This is regarding SED. So I hope all of you have gone through the SED lectures and all, right? Because to understand this one, it is good if you've already gone through that. Shall we continue on this one, or shall we take it in the next one? This is regarding sed. So instead of bash scripts, now we have to use, essentially, yeah, we'll use sed. Within bash we can also use, and we can write separate sed scripts also, either way. But thing is that you should know the sed syntax for that. Is that okay if we proceed with this now, or shall we take it in the next one? Next one. Okay. So then we'll take this one in the next one, and along with the PP also. What else? 7 is mostly done. 8 we'll take in the next one. Yeah, so essentially what comes after this is sed and awk. Okay, these two. Grep, you know how to work with that, right? And the knowledge you have of grep will help you in working with sed also. Yeah, sed is again for doing manipulation with strings and so on. Okay, so this you could do. Thing is that if you go through the sed, do some practice also. Like if you go through the sed lectures, no, that is because to understand the syntax is important to go through that. We'll explain it also how to do that. So this we can cover. After that we have awk also. Awk is more like, more closer to uh, record processing, right? So you have multiple records. Let's say spreadsheets you have, right? You CSV files, you want to go through each of them and so on easily. Then for that you have awk. Awk is like a complete programming language. Okay. So this we will discuss in the upcoming ones. Okay. All right, then at this point we'll close. Maybe we can continue in the next one from here. Any other question that any one of you would like to discuss apart from this? Okay. Then thank you for attending, and we'll close for today. Continue from here in the next one. Is that okay?
Thank you, sir.
Thank you. All right. Thanks for attending.